Uh, Good afternoon, all. Sudarshan. I'm Sudarshan. I'm the technical account manager representing on behalf of DEP. We thank you and appreciate your effort for allocating your valuable time. I'm glad to present you about who we are, how much we have evolved as a company over the last 25 years. DEP has four verticals of business. We do engineering service and work with most of the OEMs. We have been supporting them by setting up a dedicated ODC team for different customers. We also support them on the CAE turnkey projects. We have developed both software product, which is MeshWorks, and bit of hardware-based development also. DEP also support most of the companies with skilled engineers. We place them at their premises. We are headquartered at Troy, Michigan. Today, we are about 550 plus employees worldwide. We are blessed with the top-notch talent engineers who are the backbone of DEP. We support multi-industries like automotive, aerospace, defense, medical, oil and gas, heavy machineries, electronics, consumer products, etc. DEP has come a long way since its inception in the year 1998. The vision and the mission of the company is very, very customer focused. We accelerate your product development at the same time, optimize it. The history shows you like DEP has never been stagnant and always wanted to improve its capabilities on year by year. These are some of our partial customers with whom we have been working for the last 25 years. Then to Abdul, who is a MeshWorks certified technical lead. Abdul, the stage is yours.
Thank you, Sudarshan. Thank you so much for the warm welcome. So let me share my screen. So hi everyone, good afternoon and greetings. So I'm Abdul Halim. So I'm taking lead of all the Asia Pacific zone for all the pre-sales and post-sales support. So today with me, my colleagues Sai Ganesh and Ausuf have joined as a tech support team for the live demonstrations. And we have conducted this webinar last time also as an intro session. So you can please go ahead and visit in YouTube's for the first webinar as a where we will be giving all the intro about MeshWorks. And today mainly we are going to concentrate more on DEP MeshWorks. And in MeshWorks, we are going to concentrate more into the first topic, which is the modeling and meshing topic. So here, as you can see, like DEP is a CAE platform. So where like one can able to do all the kind of meshing till solving the model, and all the different types of verticals of domains one can able to achieve via MeshWorks. So in MeshWorks, one can able to perform any operation with a different set of domains, something like an automobile, aerospace, or ship industries, oil and gas, and we have been to biomedical industry, heavy industry sectors, logistics, and also now electricals. So all these verticals, one can use MeshWorks as an integrated CAE platform. And we do support all the different types of like modules, like what you see here. The detailed description of this module has been given in our last webinar. So today mainly we are going to concentrate on the very first topic, which is MeshWorks meshing and modeling topic. So before going to that topic, like I just wanted to give a brief about what is MeshWorks and how MeshWorks is impacting on the product development cycle throughout the globe. So when it comes to product development, so all the like a conceptual stage or the detail stage, virtual validation stage, or the maintenance phase. So all the four different verticals of phases of a product development, one can observe like MeshWorks is being spent only less time in the conceptual stage itself, and then there is no time at all which is being spent in the detail and virtual and maintenance phases. So when it comes to the current trend, you can able to see there is a lot of time and manual effort has been spent over the post correction of the conceptual stages. So wherein like in this new trend, one can able to achieve a lot of time saving in the meshing modeling functionalities, and also with our conceptual modules like morphing or the concept modules, like one can able to achieve more time reduction via this kind of a route. So when it comes to conceptual stage, so MeshWorks morphing and concept modules will help. When it comes to concept and detail phases, like MeshWorks CAE parametric approach and also CAD parametric approach is been used, and also topology modules. When it comes to all these four verticals, there comes our MeshWorks meshing and model assembly modules, which is what you are going to see in today's session. And when it comes to meshing, so be it any kind of a tetra meshing or a hexa meshing or a mid-plane plastics or sheet metal meshing, so all the verticals of meshing, so MeshWorks have come a long way as an automated approach of doing the meshing. So we use our machine learning algorithms to do identify the feature, something like a heat stake, dog hoses in plastics, or one can able to identify the tubes, fillets, quality failure locations, etc., and produce the mesh in a high standard way where the rich output of mesh comes to you for the solver itself directly. So where only the manual time will be very less when compared to other OEMs. So when it comes to standard connections, like so whatever the be it a bolt connection or a contact or a spot weld, adhesives, etc., so those are all the connections has been again automated into it. And one more advantageous thing in MeshWorks is so whatever the meshing you do in MeshWorks and also the connections you do in MeshWorks, it's completely getting parametric. So you can do all the parametric options in meshing and also model assembly techniques. So that is what we are going to show as a live demo for today. In this today's live demo session, we wanted to address tetra meshing and give a glimpse about our next webinar, which is morphing and parameterization. So we wanted to give some glimpse about auto parameterization, and then we wanted to cover our plastics or mid-plane meshing, then some hexa meshing techniques, and then some cool tools we wanted to convey about our 1D and 3D bolt connection tools, and 2D and 3D welding connections, etc. So all these, like, we wanted to cover it for today. So with that, I leave the stage to the tech support team for giving the live demo session. So over to Ausaf and Sai.
Thank you, Abdul. Hi, good afternoon all. I am Sai. Today I'm going to show about a tetra and plastic demos. I will start with tetra. This is a tet meshing model. Whatever the model you are seeing, it is the cut section of engine block. This is a typical casting part. Coming to meshing in MeshWorks, MeshWorks deal with template based mesh, which is an interactive batch mesher. Here we can select this component, and related to that component we can select template here. If we are having multiple components in one assembly, we can add on here and we can give same process, and I'll just execute here. Just I will give a small glimpse on how the template will be working in MeshWorks. This is our MeshWorks template where we will give parameters. Before going into template explanation, I will show you the MeshWorks library template here. Here we can see ample of templates, like all are created by in-house by DEP based on several case studies. Each and every template will be for different domains like crash and NVH. Now I'll be explaining about this one. Coming to first page, here we can see general parameters. Create feature PID, it will automatically identify the tubes, fillets, and planar surface. Coming to tubes, tubes are based on a diameter range. Here we can capture the tubes have multiple ways to capture. We can keep 4 zones of washers for tubes. Coming to fillets, here fillets are classified on based on radius and range. User can provide their own requirement to get the mesh. And also for fillets, we are having a unique tool called convex. Here we can separate like convex fillet and convex fillet. Coming to quality control parameters, before itself we can set the quality before generating the mesh itself in template. Coming to DEP mesh parameters, what layer we want, like volume layer mesh or higher order mesh, we can give it here itself, and we can save this template for later. Meshworks template is highly customizable, and also we can save it for later. We can use it for later like a similar way of components. And I will show you the previous window. This is the output after giving the template. We can see how nicely the tubes has been captured and fillets and planar surface. The mesh here itself has been become very good here. The mesh has came. And coming to tubes, here we can see it got captured very well. We can see fillet regions here. It got captured very well. Here the user no need of change any mesh flow. Directly he can go with this mesh to the modeling stage. Coming to the MeshWorks intelligence, here we can see a small sliver-like surface. By default, if it got captured here, it will definitely fare for quality. MeshWorks has identified this as a sliver-like surface, and it got projected to the machined surface. This is how MeshWorks has ability to know maintain all the machined surface edges, even after doing all flow correction and quality correction. Now I will show you the sliced view. Here we are having a growth factor like this, and we can see how nicely the mesh has been growing. Once you done all the meshing in MeshWorks, the model will be get parametric. Now we can perform parametric in this model. We are having a unique tool called auto parameterization casting. Before going into the tool, I will explain like the user is not from a morphing background. In case if you the user want to perform quick DOE study, and if you want to introduce some parameters in hotspot regions, one does not depend on morphing engineer to do that. Any FE engineer can do the morphing with this auto parameterization casting. I will show you the auto parameterization casting. I'll switch to morphing tab. These are the 4 preset parameters in MeshWorks. I will show you the fillet. Select CAD surface and just click on execute. At top right side, we can see the sensor. It is showing the initial radius. We can change the radius. Just I will unlink it. Here we can observe the radius is getting changed. CAD surface fillet we can change like this, and we can perform a quick DO here, and we can save it for later. Similarly, I will show you the tube diameter change. Just I will select the elements. Click on execute. Here at the right side top, we can see the sensor of the radius tube diameter. We can change the diameter of the tube by reviewing it. Just I will unlink it. Here, how nicely it is getting changed, we can observe. Like this, we can perform parameters in meshing. This is how one can create different kinds of parameters directly in FE models. Now I'm going to switch to the plastic. This is the arm wrist model. In this model, I'm going to explain about the workflow. Here in this model, we can see so many heat sticks, doghouse, honeycomb ribs, fillets, all. This all will be captured by using background. We are using machine learning algorithm, and it automatically identify the features known of CAD identification and identification of features. Auto generation of mesh, it automatically stitch to the base components, the heat sticks. In MeshWorks, we are having a template for a plastic also, that is auto mid-plane mesh. Just we need to select the surface, and these all options will be performing background by using the machine learning algorithm. In advanced inputs, this is the template for the plastic. Then just click on accept and execute it. It will take a couple of minutes. I'll show you the output. This is the output after generating the mesh. Here we can see how nicely the heat stick got captured, and it is also properly projected in the mid plane. Here we are having a layered fillets, all got captured very well. Here we can see how nicely the rib has been projected, and it got stitched to the base, and this all got projected in the mid plane. Coming to mesh flow, to improve the mesh flow in MeshWorks, we are having a ample of tools to do that. I will show you basic mesh editing. To reduce the trias in model, we can here we are having opposite trias. For example, if we click on this one tria and we can move, it will show the direction. In the direction we can move. Like this, we can combine the trias, and we can reduce the trias in meshing. Like this, we are having an ample of tools similar to this. Initial mesh has been came very good. Now I am handing the stage to also for the rest of the demos. Thank you.
And thank you, Sai. So, good afternoon, everyone. I am Ausaf. I am from DEP Tech Support. Now, I will continue this demo with Hexa, bolt connections, and seam welds. First, I will go with Hexa. Here we have a caliper. So, this is a shell element. So, we use this shell elements for extruding Hexa. I'll show you semi-automated hex mesh process. So this is the semi-automated hex mesh. Here we have these 4 steps. These 4 steps will work automatically. First, we'll have an input model. Then by extracting the features, it will create a surface. Then from surface, it will generate the planar mesh. And from planar mesh, it will extrude the hex mesh here, which have some irregularities. For overcoming that irregularities, we have a last step tool called hex mesher. MeshWorks has the ability to extrude hex mesh from both CAD and FE model. The shell may be like a tria and quad. It will extrude the hex mesh. Now we'll see the hex mesher tool. So here we have this hex mesher. So for this tool, we just need two inputs. One is this outer geometry and one is in cavity, which is nothing but extruded hex mesh. I will input that. So this is the extruded hex mesh. Here we have some sharp edges and irregular feature. So I'll select this as a cavity, and by giving element size and click on hex mesh, this process will execute. Here you can see we have a sharp edge. How nicely it will project, I will show you now. So here you can see how nicely it got projected. The working of this tool is this inner cavity will grow 1 or 2 layers, and it will use our morphing techniques for projecting to the outer geometry, this one. And this inner cavity will adopt the mesh of outer geometry by using plastering techniques. In this region, you can see how nicely it captured the fillet here. So by using one tool, we can capture the hex mesh fillets and features easily with this tool. And now I'll go to bolt connections. So here we have a sheet metal assembly. In MeshWorks, we can create the bolts for whole assembly in one shot. No need of creating manually. I will show you that. For that, I will use this bolt connection here. I'll select all the elements. And after clicking on detect hole, it will detect all the holes like this. But it will only highlight the regions where we need bolts, like in this region. So user can go with the fastener types and connections. So here we no need of creating property manually. This tool will automatically create the property. I'll select the material here, and user can go with the DOF if he needs any DOF requirement. So after realize, we can see how the spider element got attached with nearby shell and the linking element here. So here we have info table where we have a basic information of this welds, bolts. So here we have this realization status, whether those bolts are realized or not. So now we'll go for 3D. Previously we have seen one bolt connection for a whole assembly in one shot, with where we can reduce the time for creating bolts. And now we'll see for 3D one by using the same tool, bolt connection. Here I will select these elements as a threaded part, and I will select the unthreaded part as this one, where the bolt head will occur here. And after detecting the hole, it will detect the all holes, and it will only highlight the region where we need bolt connections, like this. As we select only these two elements, so here we got those highlighted region. So here we have this bolt defined. As we have seen templatized mesh for tetra mesh, we have the same with bolt 2. Here we have some bolt design where we can import, and here we have a bolt, different types of bolt size and bolt type without washer and with washer. And here we have a diagrammatical view of bolts, and user can go with the mesh type as a tetra and hexa based on his requirement. And here we have basic parameters which we can change. And this template, this is the customized one. We can customize our bolt here itself. And later we will have pre-tension layer here. User can go with the pre-tension layer and mid pre-tension layer. And if he doesn't need any pre-tension layer, he can go with no pre-tension layer here. And here we have this contact. This tool will automatically create the contact page between master and slave element by detecting automatically. No need of creating the contact bits manually. So after realizing, you can see the bolts here. And we have created the contact. So now we'll see how our contacts got created. So these two are our bolts. And here we have this pre-tension layers for these two bolts and the contacts. So this is how we can create the contacts and pre-tension layer for bolts automatically. Now we'll go for seam welds. Here you can see a sheet metal assembly. For this creating welds, I will go with seam welds here. In MeshWorks, we can create the welds for whole assembly in one shot with the help of this CAD curves. If we have CAD curves, we can create weld connectors. So I will go with auto connector creation here, and I will select all the elements and all the CAD lines, and user can go with the weld element type here. What this auto connector creation will do is it will automatically detect the master element and slave element, and based on that it will create weld connectors. You can see here it got created, and now we will realize the welds. As we have weld connectors, I will go with weld connectors here. For whole assembly it will take a couple of minutes, so I will just create the welds in 2 to 3 regions. So we can set the DOI for welds also, and here we have heat affected zones. If user want heat affected zones, you can go with that. So after realizing the welds, you can see how these welds got created. And now I'll show you how we created the well for the whole assembly, how it got created. So you can see wells got created in these regions here and here and here. So this is how we can create the wells for the whole assembly in one shot by using MeshWorks. Now we'll see different types of 2D wells in MeshWorks. So these are the 2D weld types. Like we have a rigid weld, beam weld, quad weld, V-quad weld, RSM welds, and quad with heat affected zones. These blue color layers are the heat affected zones here. Now we'll go for 3D weld creation. For 3D weld creation also we use both the same tool, which is seam weld. First we will select the nodes. And I will select this element as my master and this as the slave. And here in LN type we have 3 types, like merged nodes, coincidence nodes with contact, non-coincidence node with contacts. I will go with coincidence nodes with contact. Here it will automatically create the contact between slave and master. And later we'll have a solid weldment inputs here, where we have different profile options for our welds. Like we can go with flat, concave, convex at start and convex at end. And here also we have a heat affected zone. And after clicking on preview weld, you can see it didn't stitch, but after realizing it will stitch to the master and slave. And here you can see the contact with got created by this tool, and now it shows 2 contacts. So we'll see those contacts here. So this is our weld, and here we got our contacts, which has created automatically by this tool. In MeshWorks, we no need of creating contacts manually. The tool itself will create the contacts automatically by detecting the slave and master. And now we will see different profiles for 3D welds. So here we have different profiles of 3D welds, like flat, concave, convex, tapered, convex at start and convex at end. And here we have different shapes like oval, circular one and arc one. Now we'll see some different weld-made scenarios where we'll have a master slave and weld type as tetra, 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 hexa, 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 tetra, hexa, hexa. We can create different types here. So this is how we can create the 3D welds in MeshWorks. Thank you, and now I'll hand over the stage to Abdul.
Yeah, thanks, Joseph. Thanks for very nice demonstration, guys. So as you all saw, so we have extensive automated tools of doing the meshing and modeling functionalities. And also you have seen a glimpse about how one can able to do morphing in MeshWorks without even knowing the morphing knowledge. So as a parameters like how so I have created on the model. So these are all some of the live demos which we wanted to show. And the main takeaway here is like for meshing, so there is no cat cleanup is required. So there is zero cat cleanup needed for any kind of a meshing in MeshWorks. And so regarding the quality of the elements, like once you do the meshing in MeshWorks and once the output has been generated, so any of our competition tools which needs to achieve that particular quality, so we need at least of a 30 to 40% of manual time to achieve our quality. So whereas in like there is a lot of turnaround time like which one can able to save according to our mesh outputs. And also our rich output of meshes has been produced across all the different domains of tetra, hexa, plastic, sheet metal, etc. And there is no need of using multiple softwares here, like one for tetra, one for hexa and all. So all the meshing is in one roof. You can able to achieve it. And clearly you can achieve 30 to 50% of time reduction across all the meshing and modeling functionalities. So when it comes to modeling approach, like you can able to see there is an extensive automated approach of doing the modeling. So which saves a lot of time further from meshing what you saw as a time saving. And also once you create modeling in MeshWorks, like automatically the connecting the dots, like once you create a 3D bolt, like one can able to create the contacts over the model automatically. And for the entire assembly, you can able to create it. So which saves a lot of time. And also one can able to do the parameterization into any kind of weldings. For example, whatever Joseph have created the weldments. So those weldments can be parameterized with number of welds or length of the weld or width of the weld, etc. can be a parameters. So and after that, like the high standards of doing the modeling with our heat affected zone techniques to study the heat propagation for more accuracy of the results. And moreover, like you can able to see a minimum of 60% of time saving in your modeling approach with our automation tools with modeling. And with that, like today's session of meshing and modeling has been completed. So all around, like when it comes to MeshWorks, so we transform all the product developments as a CAE or a CAD domains. And also we accelerate our workflows based on like new tools, which is a ROM model or a module or some other optimization techniques, etc. And also we automate with multiple modules with inbuilt structures of automations, which has been integrated into MeshWorks already. And also we innovate new categories of modules each year and year. Something like our EMOD for our new electrification generation. And these are all about MeshWorks, and you are going to see further more live demos in our upcoming sessions. And if this session has been missed out or something, like you can watch it in YouTube.
Okay. Thank you all for joining in today. So for any more clarifications or details on MeshWorks and other details for any tool related functions and features, you can write to the email shown on the screen. Thank you for joining in again today. We will meet you in 2 weeks' time with our next session. So Abdul, we can close the session. Thank you all for joining.
Sure. Yeah, thank you all. Have a great day. Bye bye.